Just 1.5 million kilometers over our Earth is the satellite named Gaia orbiting through the galaxy, collecting data for us to piece together the evolutionary history of our galaxy, the Milky Way. This image is an artistic recreation of the actual satellite as it would be pictured in space. Gaia was launched on December 19, 2013 by the European Space Agency. It finally reached orbit on January 8, 2014. The mission was originally planned to last 5 years. We are now at 6 years and 7 months and are expecting final results in 2021. The goal of the mission is to create an accurate three-dimensional map of the Milky Way. It has also been successful by giving us additional data, such as observing asteroids and mapping smaller galaxies on the outskirts of the Milky Way. It was projected to scan roughly 1 billion stars about 70 times each over the 5-year extent. Here is what the Gaia satellite looks like. The satellite uses multi-wave spectrophotometry to measure the brightness of stars. From our understanding of the Doppler effect, it is also able to measure radial velocity. It also uses several techniques, including one called shielding, to help decrease radiation damage. The spacecraft was influenced by the former satellite named Hipparchus. The angle between the Sun and spin axis is 45 degrees, whereas the angle of the Hipparchus was 43 degrees. The satellite's spin period is 6 hours. Here is a visual representation on how the scanning occurred for the first 14 months of orbit. First, a celestial sphere is set, which lays out the area to be scanned. For the first month, scanning began by the elliptical poles as you see on the top and the bottom. When it began scanning circularly within the areas, each circle was a 6-hour scan. The first data set was released September 2016. This image is produced after 14 months of scanning. There are still visible artifacts across the image. This data release includes a position of 1.1 billion stars. It also documented light curves for 3,000 variable stars. This is the map developed after the second dataset was released in April 2018, after 22 months of observation. It charts the positions of 1.7 billion stars and obtained the radial velocity for 7 million stars. Gaia was successful in scanning and mapping local galaxies as well. This image depicts the small galaxy neighboring the Milky Way named Triangulum Galaxy, or M33. This galaxy is a spiral galaxy. Here is another galaxy pieced together by Gaia. This is an image of the Andromeda Galaxy, which is the largest of the Milky Way's local galaxies. This one is also spiral-shaped. Both of these images were created by compiling the total densities of stars scanned in those areas. Here is the first asteroid discovered by Gaia. This is asteroid Gaia 606. This image is from October 2016. This movement was discovered over several scans. Gaia uses a gravitational pull around asteroids to determine its mass. We now only know the mass for about 20 asteroids. However, Gaia is expected to measure nearly 100. That September of 2014, Gaia also discovered its first supernova named Gaia 14AAA. It was discovered roughly 500 million light years away from Earth. Gaia rescans the same area several times, so the asteroid was noticed by detecting a light intensity change occurring within a month. Saddle-Malik was one of the first stars to be scanned and identified by Gaia shortly after the mission began. This image is from January 2014. This is only one of billions of stars documented by Gaia. Since Gaia collects data from such a wide sample of stars, astronomers can more easily explore stellar evolution. So far, the Gaia mission has had great success. This video from the ESA site is a perfect example of the combined data collected by the Gaia mission. It shows the motion and placement of stars as it is changing in time. The next data release will give us even more information to learn of the Milky Way's past and present.